Hello, this is Amy with Amy Astro. Thank you for watching my videos. If you like this video, please subscribe below and select the alert bell so you know when I upload new Astro videos. Like and share with your Astro friends, and you can find me on Facebook as Amy Astro, where I share my Astro-related adventures. This video was requested via comments on one of my previous videos where someone asked me to show them how to process a color image. This is from a one-shot color camera. So we're going to use this video to show you just that. So a couple years ago, I took an image of the Crab Nebula, and this is what I edited back then. Not too bad. This was probably about 6 months into the hobby and trying to figure things out. But we're going to take the same data today and we're going to re-edit this and see how it comes out. And we can compare what we know today versus what we knew back then. Is it the same or is it any better? That's a big question. So I have the images and I took them on a one-shot color ZWO ASI 178 color cool camera, and I took a group of images, let's see, at 2 minutes worth of exposures here, and I don't have very many. Let's see how many we've got. We have 32 images to work with. Now, as I was going back and checking my calibration files, I realized that I took flat frames, but I didn't take them correctly. So this image we're going to work on today will only have dark frames and bias frames calibrated with it. And we're going to hope that it turns out okay. But what I wanted to show you real quick is what the dark frames look like, the master dark. And let's start with an original dark frame. What did one look like right out of the door? Okay. This was one of my dark frames. Now this was the problem I had with the 178 camera. It had a lot of amp glow, and I wasn't really happy with how that camera performed. But ultimately I was able to calibrate most of that out. So was it a reason for me to get rid of the camera? Well, back when I did, I didn't know what I know now, and it's probably a fairly decent camera to use. So now let's look at when I put the images together for my dark. I had some rejection frames, and that's what got rejected off of my master dark. And let's see if we can get this to wake back up. And this, let's see, that was the slope. Let's look at what the regular rejection looked like. That was the regular rejection. And in the end, this is what my master dark looked like. It's a kind of a scary looking master dark, so let's see how it works out with all that amp glow in the corners and all that. So now we know what the camera was producing. Let's see how it helps us calibrate images. I'm going to close all these up and let's go back to the images and let's look at an original image straight out of the camera, uncalibrated. And we're going to use this as our reference point. This is what it looks like right out of the gate at 2 minutes. And this was with no gain and no offset. This is just straight out of the door. So let's start with calibrating our light frames. We already have our master dark and our master bias. And if you need to know how to create those, please look back at one of my previous videos. I have one set up for just doing calibration. And whether you're on a mono camera or a one-shot color camera, the process is still the same. So let's start calibrating our light files. All right, here's all of my light files. I'm going to grab them and open them. And let's choose an output directory. And I'm going to put them in the light calibrated. Let's just show you where that's at. Let me back up one more folder so you can see that I'm following my rules here. Here's my originals, and this is where the calibrated will go. All right, let's add our master bias, and I made sure he was super. We all like super. And calibration files, and there's my super bias. And here's where we're going to put our master dark. Master dark. And I am not going to use a master flat because it did not turn out. And I'll show you what I did wrong, just so you have an idea of when you had a bad flat. And since this was almost 2 years ago, I really can't fix it. Well, actually, it was February 8th of 2018, so a year and a half ago, I took these images. So let's run our calibration. All right, we're back. Those are done calibrating. Let's clear these out and minimize. And let's find one of those calibrated files and just see what it looks like. This is just after the first step of calibration. Let's just grab one and open it. You notice I just dragged and dropped onto my screen and it automatically opens. And let's give it a stretch. So, what do I have going on here? Well, prior I had a whole bunch of amp glow, and now it's just, let's make this bigger. Bigger is better. I want to see my edges. Just like I want to see this guy's edges. Okay, and let's compare. It's almost like it took the white and reversed it to dark, but not quite as much. And the same down here in the corner. Okay, let me check this and just make sure all my settings were correct. I have the correct super bias on here, and I have the correct master dark. Don't really think I needed to optimize this because this 120 is the same as what my images were taken at. Curiosity's sake, let's run this again and see if it matters. Let's go back and grab our light frames, our original lights. Oops. I'm going to grab all of them and say open. I'm going to uncheck this, but let's put this in a separate folder. Let's call it Light Cal 2. And let's just compare. Okay, so the only thing I'm changing from the last calibration to this new one is I'm unchecking optimize. I just want to see if it makes a difference. All right, these have finished running, so let's open up one of our new files. All right, let's go to our light calibrated 2 that we just ran, and we're going to open one and compare it to the last image. Let's get this out of our way. All right, close this. Let's give them a stretch. All right, so this is calibrated with the optimization turned off, and I have to say it looks much better. So compared to this guy here, I'm actually going to run and continue my editing process with the calibrated 2 ones that we just did. Let's close this, and if you remember, I'm going to show you one more time. The only thing that we did different when we ran this set was we unchecked optimization. And that was because our dark frames were taken at 120 seconds, the same as our light frames. So we didn't need to have any additional stretching between the two. So now that that's done, let's continue on. So the next step in our process is to do our cosmetic correction, and that is to get rid of any of the extra hot pixels that our camera has created on here. So we will go to Cosmetic Correction, add our files, and let's go to our folder that has the light calibrated 2 that we created in Light, and grab all the images and say open. All right, our output directory will be this directory right here, the light calibrated cosmetic correction. And then we will use our master dark, which is the master dark 120 seconds. Okay, so now we need to open an image. Let's double click on one of these. Move this guy out of the way a little bit. Let's make him larger. And let's give him a stretch. Okay, so we need to zoom in a little bit on this image and see if we can find an area that might have some hot pixels. Now, I'm going to be honest, this image has been rather difficult locating hot pixels. I know they're there, they're just hidden and just not jumping out. But typically my image, you would see this white dots everywhere. So you would be able to home in on a location. But I'm going to work in this area right here. I think there might be some around here and maybe some around here. So I am going to create myself a preview window. And I'm going to drag it where I think I've got some hot pixels, but don't grab any stars. And we're going to open that preview window and zoom in so it's kind of big on our screen. And now let's do a real-time preview window. So this is what we're working with. All right, I will go ahead and check the enable button. Let's see, typically my sigma would be all the way up here at 50 when I open this box. So let's check enable. And let's slide this down to the left, and over on the left hand side, watch for pixels to start disappearing. And as you can see, I've got a real quantity count right now. It says I'm removing 55 pixels. And we're going to slide this down between 3 and 2 and see if we have any pixels disappearing. So there's 3. Do we see anything popping off our screen? Not really. I mean, I see pixels starting to disappear right here, but at this point I am trying to delete 174,238 pixels. Chances are a lot of that is good data and we don't want to delete that. So in this case, I'm going to bring this back up to close to 3. And let's see, we're at 2.97, and this has me deleting about 10,372 pixels. That I can live with. Okay, so now we are going to apply global. Now I ran this a couple minutes ago and forgot to hit the record button, so I've already run this process, but when it's done it will come back in the process console and it'll tell you that this many images have successfully gone through cosmetic correction. Okay, so now we're just going to go ahead and close these out once the cosmetic correction process is run, clear our images, and we will shrink this back up. And the next step is we need to start realigning our colors pixels, and that's going to be with a process called debayer. So if we go up there to process to color spaces and hit debayer, okay, you can leave this on auto if you like, but if you know your mosaic pattern, then it's always best just to go ahead and select it. I typically work with CWO cameras at this moment, and they are all at a pixel pattern of RGGB. And you can find this in your specs for your camera on the manufacturer website. So let's come down here and we will add our files. And these are the files that we just got through cosmetically correcting. So we're going to grab all of those and say open. Once they are open, we will give them an output directory. And that output directory will be the one that ends in debayer. And we will say open. And that's all we have to do. Everything else stays as default. And we go ahead and we apply global. All right, our debayer process is just finished. I'm going to go ahead and clear this and minimize. Now, I'll just push that over there. The next step is going to be, it's time for us to approve these images. So I'm going to go use, under batch processing, subframe selector. Now I have been told there is another process under here that will allow you to do it that's quicker, and I need to investigate this further and give it a try, but as soon as I figure it out, I will show it to you and we will learn it together. All right, so let's clear this and add our files that we just got through running through the debayer process. And open. I'll tell you what, doing a one-shot color image is a whole lot faster than dealing with the mono. Okay, so right here is where I need to find out what my camera scale is. And I have a cheat sheet that I created a long time ago. Back every time I buy a camera, I write this down. So I have come back and found out that my camera scale is 2.4 arc seconds per pixel. And did I put a point there? I think I put a comma there. 2.4. And you can look this up with using the astronomy.net website. And let's see if we can find that really quick here. I've got a shortcut. It's somewhere right there, astronomy tools. Remember, I showed you this a video ago, but if you come over here and you can select your telescope and your camera, and it's got this whole pull down menu, you just find it. And if your scope's not in there, just manually fill out these numbers. They're all in the camera specs on your manufacturer's webpage. And once you say add to view, it will calculate your scale, and you grab your scale, and that's the number that you plug in over here. I leave the camera gain at 1, and let's see, I think it was a 12-bit camera. You know what? I guess I better go look, shouldn't I? I just want to make sure I know what the bit rate is. It's a 14-bit camera. Perfect. All right, so we're going to take that information and change it from 12-bit to 14-bit. And we've got our 2.4s, our pixel size and scale. That's good. And all this I left as default. I only change it when things don't start working. Okay, and here's my expression that I like to use. Full weight half measure is less than 6, and eccentricity is less than or equal to 0.071. Once I start to get to 0.72, I get elongated stars, and I don't like elongated stars. All right, let's go to the output. Let's put it in our directory. Here's the directory we were just in. That'll help. And we can go backwards. I still like how Windows does their directory structure better. Okay. And keyword, we'll add SS weight. All right, let's do the first step, which is measure. And this will take a couple minutes. All right, so that was a nice little break. Got up, got myself a new set of coffee, and oh my word, something is seriously wrong here. None of my images are checked. It didn't approve a single one of them. Now, why is that? My eccentricity is all within reason. I don't have any crazy stars. Oh, let's look at the size of these stars. These stars must be too large, because this is a smaller scale camera. So I bet you that my 6 was way too limiting. It's my expressions, where I said everything less than 6. Well, less than 6 worked well for my mono camera, but it did not like it at all for this one. So what could this mean? This could mean that my image is not really in focus, or that my stars are just a little bit bigger in this image. I'm kind of leaning towards not really in focus, but I'm going to go ahead and I'm just going to push these guys through, and I'm going to accept all of them. I don't have to listen to the subframe selector. If I don't think it's correct, I just push them all through. So let's just check them. What's the worst that could happen? I get down to a single image and I say, oh my gosh, I do not like this. It's only another step, so what, another 10 minutes of my life to figure this out? I think we can handle that. So I wonder if I can grab several. Nope. It's going to make me do each individually one. All right, here we are, down to the bottom. And it said let's do a sort on the size of the stars. Oh, right here. F image. I'm just curious. The smallest one is 11.66. The largest is all the way up to 19. I would like to compare this image. Let's find out the image name. Image name, he starts with, oh, this is back when I named them differently, so I'm trying to figure out how do I find this image. The timestamp. Let's find the timestamp in there. 20, 26, 18. All right. I want to look at that image. I'm going to write that down real quick. 20, 26, 18. We're going to go back and open that file just to compare it in a couple minutes. Let's get this done and output, and we'll be back in just a couple minutes. All right, so we're back. That's done. Let's dismiss this. But first, I want to see what the smallest one was. What number was he? He was 21, 3615. If I move the mouse, I won't be able to point out, but he's down towards the end, and I believe that's the time that these were taken at. Let's dismiss. Yes. Okay. Now here's that first image that said it was the biggest set of stars. Okay. It is a bit out of focus. This was back when I was manually focusing things. So we've come a long way. Let's find 21. Let's go over here. I'm looking for the number 21, 36, 3615. That image. Let's open it up. This one was the smallest one. All right. You know what? I will say, if you were to compare these two images, let's back up one step. So they're about the same size. Look at that. This one that it said that it was the largest is out of focus. This one that it said was the smallest is in focus. So there is something to that half weight full measure number. So maybe for this camera, I just needed to find out what's the maximum number that would be any good. But I already know this one's bad. I should have written down the other ones just to find out. Don't think, let's see if it's written. I think this clears out. Yep, everything clears out, so I'd have to run this process again just to see. All right, let's dismiss. Let's close these up. But as you can see, I have color in this image now versus when we started. And this is because I have gone through the debayer process and it has juggled my RGB files. Okay, so what I'm going to do is, we know that last one was not very good. I'm just going to take him out of my mix. And let's find him again. He was 22,618. And there's nothing wrong with losing these images again. And you know what else I could do? I could run the blink process on all these. It's not necessarily too late to do that. Let's run a blink and just take a peek at that. We ran through the blink command in our last video. And let's see, let's add our files. And I believe the last step we just did was the approval step. Let's grab everything but that bad one and open. And let's just see if there's anything obviously out of focus that I just don't want to work with. Oops, come on. Goodness, what is it doing? Let's hit the first one here. So it's running the screen transfer function for each individual files right now, not based off of the first file. All right, it's finished doing its little screen transfer function. Let's get the screen organized a little bit here so we can see what's going on. I'll say that this image is a little bothersome to me. Whoops. The mouse and the zoom, they're not agreeing with me today. Okay, let's make this bigger. And let's push him up. All right. Now what I forgot to show you back in the blink command is, if I didn't want to sit here and hit the down arrow all the way through, I could choose one of these times. If Watch this, I'll hit the play button and it's going to truck through all of the images. Now doing this makes it a little bit harder for me to stop it and figure out which one was causing me problems. I do see a lot going on with these corners and that's a little bothersome, but considering this image is so small, I'll be cropping them out anyways. So with the camera that's got some amp glow going on, maybe you should take that into consideration when you're planning your image. And just know you're going to be cropping. All right, I'm going to stop this real quick and let's go up to the top. And I want to zoom in just a little bit. And I want to determine who's out of focus. I'm going to hit the, oh, there's the first image. I'll hit the down arrow. They look about the same. You know that. He does look like he's a bit out of focus. Now what I did find out is if I uncheck these, the next time I run the play button, it will skip over this image so you won't even see it, which is helpful when you're trying to decide. Ultimately, I think this night my focus was just not that hot. But that's okay. We all take questionable photos. It's just part of the game. I'm going to uncheck a couple of these, just because I'm looking at how this one star is reacting. It's almost like my focus was changing. Now I did take these back in February. I'm in the South. It was most likely pretty cold on that day. So a lot of different factors. But if you're going to get any better at this, you really just have to go out and take images. You have to practice on those cold nights, on those full moon nights. Just get out there. All right, I'm going to go ahead and reject just a couple of these. So let's go back to this option here where I'm going to move these files to a selected location. Oops. But first, we have to select those files. Remember, that checking was just for me. I'm going to select him. I'm going to hold down my Control or Command, select, and select. I'm going to ditch 3 files. And let's move them to another folder. Let's call him Bad Images. Feels like I'm punishing my images here. Let's put them in there, open, and now they're going to be out of my directory. So here's my directory. There's that one that I had automatically named as bad. Let's move him out of the way. And these are my good images that now we are going to register. And just because I purged those few images does not mean all these are going to register. So let's start the next step. Let's close all of our files right here and minimize him. And let's go to star alignment. We're going to star align off of an image. And you know what's a good image for us to align off of? It's that one that had the smallest star. And that one had the 20, 26, 18 in it. 20, where'd you go? Oh, now that would be really funny if he was considered a bad image. 2026. Oh, that was my bad image. What am I thinking? I am looking for 21, 36, 15. 21, 36, 36, 15. 21, 36, 15. That's the image that had the smallest stars. It was the most in focus, and that's what I'm going to align everything off of. And I'm going to create my drizzle data. Let's add all of our images. Go back to this directory. Let me shrink this up so I don't accidentally grab them. And these are all the ones that we deemed as being okay, decent, good enough to work with. Let's give us an output directory under lights, and that's going to be this here where we've calibrated everything, we've cosmetically corrected, we've debared, we've approved them, and now we are going to register them. In other words, we're aligning our stars with each other. Okay. All of this I will leave as default for right now. If for some reason my images don't start registering, I will adjust the detection scales to see if I can get more to align with each other. We already know the images are the same, but sometimes if there's not enough stars for it to find, it just won't register. Okay, so now we are ready to align our images. Now let me show you something real quick that I just realized. I had accidentally pressed the square button, and the square button is for apply. And what it did is it applied the star alignment to this image, and this image only. So I came up on my screen with the grayscale image that didn't seem quite right. My directory had no images over there as being registered, so I knew something was wrong. And I came back and I realized I needed to press the circle, which is apply global. So I just did the apply global, and it came back, and my process said of these images, 28 succeeded and 0 failed. So that means all my images successfully aligned. So life is good right now. And now that they are aligned, it's time for us to start integrating these images into one. All right, so let's see if all this worked out in our favor. Let's go to image integration. No, you know, I lied to you. I am so sorry. We need to do our local normalization. What was I thinking? Okay, let's go back to our registered files. I want to find that file that I just got through aligning everything off of because it was really good. Now, normally I grab the first one, but in this case we did something different. We grabbed that one that has that 21 number in it, 213615. He is the one I'm going to normalize everything off of. I'm going to generate my normalization maps. I'm going to leave all these as defaults, and let's add our files. We're going to add all of our files that were in the registration folder. Okay, and this image, notice it's also been registered with the R on it. Just like all these images have the R, you want them to match. And let's output our files to the same directory with the registration. And let's say open. All right, and now we are going to apply global, the circle, and let it run. And this will take a couple minutes also. All right, that process is finally done, and it took a long time. I was able to brew a whole pot of coffee with that one. But we are local normalized now, and they all succeeded. So once again, life is good. Let's reset this and minimize him. And now for what we have all been waiting for. Let's integrate this image. Let's add our files. We're grabbing all of our images right now. Make sure they're all selected. Open. We're going to add all our normalized files. Let's grab them all. Make sure I got them. Open. And let's add all of our drizzled files. Now let's grab them and open. All right, so we're going to do a combination of average, normalization. We are going to use local normalization because we just got through normalizing our images. Our weights, we're going to use our fits keyword, which remember back in the approval process was SS weight, SSWEIGHT. Okay, we're going to generate an integrated image. We're going to generate our drizzle data. We will let it evaluate our noise once again. Close that up. All right, our rejection algorithm. How many images do we have? We have 28 images. Excellent. So we can use my favorite, linear fit clipping. You can use this one anytime you have over 20 images. Normalization will be our local normalization again. Let's take a look at our rejection maps this time, and I'm going to turn this one off, the map range rejection. I don't care about that. And I don't care about clipping the low range. We're just going to clip the low pixels and the high pixels. I don't want any obviously dark or obviously white. Okay, and I don't need to do anything there, and nothing there, and nothing there. So let's run it, and I'll be back in a couple minutes, and hopefully we have one successful image. All right, so that is now done. We have an integrated process. Are you ready to take a look at it? Do you want to see the image first, or you want to see the rejection first? I'm a rejection type person. Let's see what it looks like. Let's give it a stretch. Ooh. All right, that's why I like the slope so much. It peels off all this extra that it thought was bad. Yeah, let's see what the high level rejections are. Oops. I want to see him bigger. Give him a stretch. Okay, so it rejected some of this stuff, but notice what it's also rejecting here in the corners. So I think my mouse needs to be recharged. So I'm hoping that because it's rejecting those corners, that our final is going to look good. All right, now here's our rejection low. I'm going to give him a super stretch. Yeah, let's blow him up some so we can see. Woo. All right, you can see where images got misaligned during the night. Okay, now this is what's been rejected. Let's push this off to the side. And we will decide, did it help it or did it hurt it? Gosh, I hope it helped it. Like I said, it's been a while since I looked at these images. All right, let's start our drum roll. Let's make this puppy big. Okay, here we go. You ready? 1, 2, 3, stretch. Whoa. Okay, so my corners are still not great, but let's look at it this way. Remember what our amp glow looked like in our original photo? I don't really have that now, but I have some where I just couldn't recover. It added something going on here, which it looked fine over there, but maybe a different image looked different. And it's almost like where it was really, really white was just too much for it to handle. You can see the corner of, let's see, over here. This corner was really, really white. And down there. Now maybe if I had my flat files, this could have calibrated out. So I'm going to have to dig through my archives and see if I have any other images that we can work with. But this is a really good learning tool. We're going to stop this video right here so you can go ahead and take a break, and when the next video comes back up online, we will pick up exactly where we just left off. I appreciate your time and thank you so much for watching this video. If you like this, please take a moment and subscribe and select that little alert bell so you know when I upload the next video. Until next time, I'm going to leave you with a little tease photo here, the final version of the Crab Nebula. Until next time, this is Amy with Amy Astro. Clear skies.